Hi, my name is Hafiz. So, today I will explain about player class. This class represents the main character and handles core gameplay mechanics. So, we will focus on three key aspects, which is encapsulation, implementation, core functionality, and visual testing. So, first of all, I will show you the player HPP. As you can see here, our player class encapsulates all player-related data and behaviors. So, means private members including position, life, and score, while public methods provide control access. That is how we have implemented. For the constructor, for initialization, here, the constructor. The constructor for initialization and the accessors like get score, um, here. Here is the accessor. Mutators like jump, here. Here is the mutator. And we also have helper methods like this jumping to detect whether it is jumps or not. So now let's see how it works. We have created a player instance at position 100 and 500. As you can see here in line 18, we set it as 100 and 500, which is 100 is x-axis and 500 is y-axis. And we name it as test case. So I will show you the demo. So we will run. Show you how it works. So I will compile and run. So it will take times. So here, as you can see here, player class test. If we press up arrow, so it will jump. If you press up, it will reset. If you press escape, it will exit. So now we see our games. So here, as you can see here, position is 100 and 370, and jumping is no because we not press up arrow yet. So if we press up arrow, so it will show yes. It will show yes. But if we press it multiple times, for example, I will press it 3 times in a row. 1, 2, 3. So see, it will just jump once because we have this jumping method that we control the jumping. It will not redundant. So we also have the life is 3. So if the score is greater than if the score is greater than 1000, it will increase 1 life. So if we press R, so it will reset the score. As in our method, we also have the reset method, so it will reset. Then if we press escape, so it will shut down the games. So I will show you my player class. Here is my player class. We have player constructor to initialize player properties. And we also have the player characters on screen, so how it will display. So just now we show you the cat PMP means that we import pictures from the outside and we display it in our image. And we also have this player position and each frame. And we also have player jump by applying upward velocity, points to player score and check for life bonus. Here, the life bonus is when the player reach 1000 points, so it will increase 1 life. So reduce player life count by 1 and increase player life count by 1. Reset player to initial state. So this is for if we press R just now, so it will reset the player. So this is just aggregator for player current score, aggregator for player remaining life, to check if player is currently jumping, aggregator for player's name, and here is to check the collision between player and obstacle. So this will be explained from Hafiz after this. So in summary, our player class will implements encapsulations through access control. We will manage all player state internally and provide a clean interface for game interactions. It will work correctly as verified visual testing, and this foundation will allow seamless integration with other games components like obstacles, game, and movement. So that's all from me. Thank you.
Hi, my name is Muhammad Hafiz bin Rafi, and today I will just take out the class obstacle. So we have the three file here: declaration file, implementation file, and the main file. I also include the bash image and the dustbin image. We have three obstacle: the bash, the dustbin, and the block. The block one we have to draw using the graphic function. So let's go in the declaration file first. So we have we have base class, which is the obstacle, the protected specifier contain this one is the for the starting position, the width, the height, the size, and for the speed. And we also using constructor and apply polymorphism method for this one, which is virtual method for the virtual destructor, and then we use pure virtual method for the draw, where we have to equal to 0 here, and then also virtual method for the update. So we have the getters here, and then we also have the three derived class from the obstacle. We implement the inheritance concept here. The bush inherits from the obstacle, and the dustbin inherits from the obstacle, and also the block inherits from the obstacle. Now let's move on to the implementation part. So we use the constructor to initialize the position, size, and the speed of the obstacle. And then in the update position is where the movement of the obstacle will be, and the speed also. And then in the in the bush, we are using the constructor chaining. This shows the chaining. For the function draw here on the bush derived class, we have the draw, right? So this where we will loaded the image of the bush and then set the outline color. This also same goes for the derived class of the dustbin and also the block. But for the block one, we draw it using the function graphic, and we set it with brown color. So next we move to the main file. So we set the size of the windows, and then we create the obstacle, each of the obstacle, and set the starting position. So let's try the game. Oh, I mean, let's try the obstacle. Let's try run the obstacle. So as you can see, it is moving from left to right as it is what we intend to do, as it is what we expected. So it's working. That is all from me for the obstacle.
Hello, my name is Muhammad Aliff and I'll be presenting the movement class. This class is responsible for handle basic vertical movement such as jumping and applying gravity. Let's move to movement.hpp. For the header file, the file contains the class declaration. So it has four private attributes. For example, velocity x, velocity y, gravity, and jumping. These variables are marked as private to apply encapsulation, ensuring they can be accessed directly from outside the class. To manage this value safely, I provided an accessor functions like get velocity x, get velocity y, and is jumping. I also added rotator function such as set velocity x, set velocity y to allow control modification of the values. The class also declares three key action methods such as jump, apply gravity, and stop jump. And now let's move to movement.cpp. For movement.cpp, for the first one, constructor, that initialize all movement related values. For example, jump checks if the object is not already jumping, and then sets the jumping state and applies an upward velocity. For apply gravity, it adds the gravity value to the vertical velocity if the object is currently jumping, and then simulating the effect of falling. And finally, stop jump. It reset the jumping state and set the vertical speed back to 0, which will be used when the object hits the ground. So this class is designed to be reusable in other classes such as player, and for example, if a player class contains a movement object as one of its members, that will demonstrate composition because the player class own and manage the movement. That's all from me. Thank you.
Hello guys, now I will move to the next part, which is about the game class. And in this game class, I able to analyze the project design and identify association relationships among several key classes. For example, the game class has an aggregation relationship with obstacle objects like brush, dustbin, and block, which all inherit from a common base class obstacle. The game class also composes a player object. This means the player is created and managed entirely within the game class lifecycle. This shows clear use of composition and aggregation. It fulfills the first requirement. So as you guys can see, this is where we use the aggregation, the pointer, and we also use the composition on the player. Now let's move to the game.cpp. After that, I also able to implement the class with by using inheritance and pointers, where each obstacle like brush or dustbin overrides function like draw and update. The game class stores these as pointers in an array of base class obstacle. So as you guys can see, this brush and dustbin is inheritance and using dynamically. So it also using pointers. This also shows a polymorphism in action, where different types of obstacles are handled in a single uniform array like this. Alright, now let's move to the third requirement, which is I managed to separate my classes into HPP and .cpp like this. This is header file and this is CPP. Fourth, now let's move to the using WinBGI as a graphics library. I managed to use WinBGI optimally, where as you guys can see, this is the proof that I use WinBGI. So this is set text style and out text t, which is will draw and animate the game. So the player can jump using the up arrow key or enter, and the obstacle will move from right to the left. So the collisions also reduce lives, and the game ends when all life are gone, and it will appear the score of the character of the player run. So that's right. So let's compile first. So we can use this compile run, and there it is. It will appear the okay. This is welcome to Leaping Kitten. Okay, the player it say that press up arrow or enter to start. So we press up. So what will happen is we will find that the cat can jump, and when it collects to the obstacle 3 times, it will gone and the game will be over. So this is the score. So in summary, as you guys can see that I managed to implement the both aggregation and composition, and the class have idea and implementation file, and the graphics are built using WinBGI, and the game meets all the functional and structural requirements and provides a simple but working demonstration of object-oriented design in C++. Thank you for your time.